So today we're going to be proving the derivatives of sine x and cos x using the Newton quotient and observations of the graph sine x and cos x. So first off, we're going to be putting in f of x plus h for sine x, which is just sine of x plus h. Now, looking at our trig identities, specifically the compound angle identities of sine x plus h, this is just equal to sine x cos h plus cos x sine h. And we can plug that right in. And then f of x just equals sine x. So now, using the Newton quotient and using proper limit notation, we can plug these in directly using the trig identity we just discovered. So sine x cos h plus cos x sine h minus sine x all over h. Now we're going to try and pair up some similar pieces here, so namely the sine x's. So I'm just going to move the sine x over in between the sine x cos h and the cos x sine h. So sine x cos h minus sine x plus cos x sine h all over h. And now we can common factor out a sine x. Sine x cos h minus 1, which is all over h. And we can also separate these. So I'm going to write another limit notation over here. Perfect. And then, since these terms here have an x in them and our limits h approaching 0, then we can take the x outside of the limit, considering removing the x won't affect it because the h approaches the limit and not the x, so it will not be directly affected. So we can take the sine x, and we're left with cos h minus 1 over h. We can take out the cos h also, and we have cos x as the limit h approaches 0, sine h over h. And now here's where our graph observations can come in. So regarding the graph of cos, as you can see here, as the graph of cos, cos approaches, as x approaches 0, the y approaches 1, and in sine, as x approaches 0, y also approaches 0. So we can rewrite our equations as sine x, and as h approaches 0 to the 0, because as x approaches 0, y approaches 0, plus cos x, and in the cos x graph, as x approaches 0, y approaches 1. So we're left with just 1 in that bracket, and again I'll show you. As sine approaches 0, x approaches 0, or as x approaches 0, y approaches 0, and as x approaches 0, y approaches 1. So then we are simply just left, these cancel, we are simply left with cos x. Therefore we can see the derivative of sine x is cos x. So now we're going to be proving the derivative of cos x using our newly found proof of sine x equals cos x. So we'll first start by just writing out cos x and using one of our transformation / cofunction identities, cos x here equals sine pi over 2 minus x. So since we know that the derivative of cos x is sine x, or sine x is cos x, then we can rewrite sine x of pi over 2 minus x equals cos of pi over 2 minus x. Now, we can use the chain rule here, and using our newly found proof, to find the derivative. So we have cos x, derivative of the outside, and the inside was just -1, which equals negative cos x pi over 2 minus x, which, using another trig identity, cos pi over 2 minus x equals sine x. So we are left with negative sine x, and then therefore we can see that the derivative of cos x is negative sine x. Now we can use the graphs of sine x and cos x to observe the different derivatives we find. So using the graph of sine x, at 0 we can see the slope of the tangent is positive 1, and at pi over 2 the slope is 0. At pi it's negative 1. At 3 pi over 2 it's 0, and at 2 pi it's positive 1 again. Now, using these slopes of the tangents, we can begin to graph another function. So at 0, 1, pi over 2, 0, at pi, negative 1, at 3 pi over 2, 0, and at 2 pi, 1. And as you can see, this graph is the same as the graph of cos x. Therefore, the derivative of sine x is equal to cos x. Now, looking at the cos x graph, you can again observe the slope of the tangents. So at 0, the slope of the tangent is 0. At pi over 2, the slope of the tangent is negative 1. At pi, the slope of the tangent is 0. At 3 pi over 2, the slope of the tangent is positive 1. And at 2 pi, the slope of the tangent is again 0. Now, using these slopes, we can begin to graph the next function. So at 0, 0, pi over 2, negative 1, pi, 0, and 3 pi over 2, 1, and 2 pi, 0. Now, this may look something like our sine x graph, except it's flipped. Therefore, it's the negative version of the sine x graph. So there we can see the derivative of cos x is equal to negative sine x.